Hello and welcome back. An unusual problem. Um, it says if A is greater than B and B is greater than 0, so essentially this says A and B are positive numbers. Find the minimum value of 4a squared plus 9b squared, the whole thing over 5ab. Sometimes when you have a lot of you know a lot of maths, sometimes you can be swayed in the wrong direction, and typical things that can slow you down with a problem like that, slow you down to finding how to do it, is you might be thinking number theory. Although nowhere does it say a and b are integers. Looking at expressions which look like that, you might be thinking arithmetic mean, geometric mean, inequalities. But the problem is actually a lot simpler than that. It requires nothing more than year 12 maths. Without anything specialist, just a standard A-level course will suffice. But is this enrichment? Absolutely yes. You will not get anything like that on your exam because it's very difficult to see where to start it and what techniques are involved in there. Let me just you can pause and give it a go, but if not, we can obviously see how this is done. Apologies about I might be making mistakes. The 9th video I'm recording today, so I'm a bit tired. My cough is very, very bad. So I'm going to start by splitting this fraction. So 4a squared over 5ab plus 9b squared over 5ab. And I notice that when I do that, I get 4/5. I got more a on the top, so I'm going to have an a on the top and a b at the bottom. And similarly, 9 over 5, this time I have more b at the top, so it's b on the top and a at the bottom. And I can write this as 4/5 a over b plus 9/5 b over a. And now if I say let x is a over b, and I notice from this line here, if a is bigger than b, and they're both positive numbers, that definitely has to be bigger than 1. So think about it, I don't know, 4.5 and I don't know, 2. It'll definitely be a bigger number since a is bigger than b. So I can say this is equal to 4/5 of x plus 9 over 5x, because that's a 1 over x. Actually, let me just write it here now, because I'm going to need to write it on the other side in a minute. So this is what I've got. So once I call this function of x 4/5 of x plus 9 over 5x, I think the problem becomes a lot simpler because I can think of calculus now. Calculus will find you local minima and local maxima, which then we have to worry about, because it says here the minimum value. How we're going to prove it that this in fact is a absolute minimum. So let's do the usual stuff. So f dash of x is 4/5 minus 9 over 5x squared. You can verify this by putting an extra line in there. And I have to write here on the original function that this, in fact, your x is bigger than 1. Okay, solving for 0. And what happens there is we have 0 is 4/5 minus 9 over 5x squared. Maybe multiply by 5 is a sensible thing. Maybe separate sides. 9 over x squared is equal to 4. You can do many things here. I mean, I'm just in case you wonder, sir, cannot see how to solve this equation. I hope I still can. X squared is equal to 9/4. X is, of course, plus or minus 3 over 2. And x has to be equal to positive 3 over 2 because x is bigger than 1. Okay. So the next thing I can do is to find, I'm going to do it so I have it ready, and then I will do my justifications. F of 3/2. So I'm opening another little window here. I hope it's visible. Let me just give you myself a just check that it does show on the video. Yes, it does. So we have 3/2 here. So that is now f of x. So that's 4/5 times 3/2 plus 9/5 times 3/2. So this is now, I'm not going to cancel across because I have no space here and I'm going to make a mistake. 12/10 plus multiply top and bottom by 2. So that's going to give me, you can use a calculator, I guess, over 15. So that's going to give me a 6/5. That's this bit here. And that's also 6/5, bizarrely. And therefore, this is going to give me a 12/5. Well, what's that 12/5 that I just found? Is either it's a local minimum or a local maximum. And I need some justification. The justification, let me just circle that a bit here. So this is the number. What is it? I'm going to do it by some kind of graph and a little bit of analysis of graphs. So first of all, this is just the first quadrant, x and y. My graph only exists from 1 onwards. Okay. So what does this graph look like? If x gets very large and positive, so we're moving far away in this direction. Let me just use probably this kind of color will be good. If it gets very large and positive, this term vanishes. This becomes infinite. Very huge number, 9 over something very huge is gone. So the graph looks like 4/5 of x. So it looks something like that. Here. So in this direction, it looks something like this. If x gets close to 0, I know we cannot go to 1, but we'll draw it there and then we'll see what happens. If x gets very close to 0, now this term disappears. So that's practically gone. But if we put 0 there, 9/0 becomes positively infinite. So it looks something like that. And therefore, the graph must look something like that. And the minimum that we just found there, which occurs at 3/2. So that's the 3/2 here somewhere. This part is not there. I've just done it there so I can graph it. Okay. Let's make it a little bit steeper as well because we can barely see the minimum there. It's something like that. So it should have been more like this. And of course, the corresponding value of y there was 12/5. So this has coordinates 12/5 and our x value was 3/2. It doesn't actually say to us to find the individual values of a and b in this particular case. It says to us, you know what, for all values of a and b in there, which satisfy that, find the minimum value. And this graph, the way we've done it there, suffices to show that the minimum value, min value of 4a squared plus 9b squared over 5ab is undisputed 12/5. Okay. Was that problem hard? Yes, I think if you don't see where to start it, this is a no-go. Okay, but I'll be interested to see if there's any other method for solving this particular problem. For the time being, I'm signing out. It's the last video of the day. I'll see you very soon with more stuff. Bye for now.